Let's talk about some of the mathematical operations on infinity, like 1 plus infinity and 2 plus infinity and infinity squared, and how that works and how many infinities are there. But I wanted to let Neil deGrasse Tyson set this up on the Joe Rogan show. And he actually makes a bunch of errors that I'm going to correct. So let's hear what kind of BS Neil deGrasse Tyson has to say about infinity.
Except, there is, I don't know how many people know this, but often it's mind-blowing when you learn that some infinities are bigger than others. Joe Rogan just leaned 2 feet away from the microphone.
How's that?
Yeah, not all infinities are the same size.
But if it's infinity, then it's infinity. It's
Well,
infinite. What is
well,
no?
okay. Don't you remember when you were a kid? They said, what's the biggest number you know? 1,000,000. Well, there's 1,000,001.
Right.
Okay, how about a billion? Well, it's 1,000,001. The annoying kid always added 1 to it. Okay, how about infinity? Well, infinity and 1.
Right.
Okay, well, it turns out infinity and 1 and infinity are the same number. Okay, so here's the, so for example, the number of counting numbers, so 1, 2, 3, up to infinity, okay?
Right.
The numbers you would use to count things, that's infinite. The number of irrational numbers, so the numbers that you cannot represent as a fraction, okay? That, there are more of those than there are counting numbers.
Whoa.
By far. So these are orders of infinity. Then there are more transcendental numbers than there are irrational numbers.
What's a transcendental number?
So that's a number that you'll never find as a solution to an algebraic equation. So pi is a transcendental number, e is a transcendental. These are magic numbers that show up in mathematics. And turns out there's like an even bigger infinity of those than there is of these other 2 classes of numbers. And they use the Hebrew letter aleph in ranking. So it's aleph 1, aleph 2, aleph 3, aleph 4. I think there are 5 levels of infinity. So my point is, just because there's infinite universes, to me, doesn't mean there's infinite conversations that have happened.
Neil deGrasse Tyson just said that there were 5 levels of infinity, but this is not correct. There are an infinite number of infinities. You can always construct an infinite set of strictly larger cardinality by creating the power set. The power set of any set is the set of all subsets of that set. So for example, with finite sets, if you have a set of, say, n items, and then you construct all the power set of that, every item is either in the set or not in the set. So the cardinality of the power set is 2 to the cardinality of the original set. Because it's like having a binary string of length n, where the string represents membership in the power set. 0 means it's not in one of the elements of the set, and 1 means it is. So you can do the same thing with infinite sets. If you have an infinite set, you construct the power set of that set, and you'll get an infinity that's strictly larger. So to say that there are 5 levels of infinity is completely wrong. There are an infinite number of infinities. And now I also wanted to go over some cool infinite math. How does the arithmetic of infinity work? Let's fill in this expression with either an equal sign or a greater than sign. Infinity plus 1 equals infinity. This is the famous Hilbert's Hotel, where suppose you have a hotel with an infinite number of rooms, and then a new person comes to the hotel that wants to check in. And suppose the hotel rooms are numbered 1, 2, 3, 4, 5, 6, and so on. And they're all full, all the rooms are full. And someone shows up to check into the hotel. Can they accommodate them? Well, the answer is yes, because everybody just moves up 1 room. Whoops. The person in room 1 goes to room 2, and simultaneously the person in room 2 goes to room 3, and so on, and so that leaves an open room. So infinity plus 1 equals infinity. Now let's look at 2 times infinity. Is that greater than infinity or equal to? Well, that's equal to. The number of numbers on a line segment of length 1 equals the number of numbers in a line segment of length 2. You can construct a bijective mapping between the two. Okay. How about infinity squared? This is kind of interesting because infinity squared is kind of like the number of points in the plane, like or a two-dimensional object. If you had a two-dimensional box versus a one-dimensional line segment, you might think that the number of points in the two-dimensional box was strictly greater than the number of points in the line segment, but in fact these are equal. And you can construct a bijective mapping by just interleaving the coordinates. You have one number on the line segment. You can turn that into two numbers by taking every other digit as, say, the x-coordinate and every other digit as the y-coordinate, and that gives you a one-to-one bijection between points in the plane and points on the line. But now here's where things get interesting. Well, since all the other ones were equal signs, you might think 2 to the infinity is the same as infinity, but in this case it's strictly greater, and this is what tripped up Neil deGrasse Tyson. This 2 to the infinity is the cardinality of the power set, and I'm kind of abusing notation here. When I write down infinity, I mean it's sort of the same infinity. We could give it an Aleph number, but 2 to the infinity is the number of elements in the power set, which is always strictly greater than the original set itself. You can never construct a bijection between a set and its power set from Cantor's diagonalization argument. So here's some of the cool arithmetic of math. This infinity squared, it also applies for infinity cubed. The number of points in a cube is the same as the number of points in a plane, is the same as the number of points in a line, which is kind of interesting. And there's some arithmetic on infinity. Thank you very much.